Welcome back to another video. Here we come up with another one problem regarding RC low pass filter. RC low pass filter will act as an integrator. So the question is, design an integrator circuit to integrate an input square wave. So here the input waveform is a square wave, and that square wave, it's a given data. The The amplitude here it is given as 10 VPP, that is peak to peak. So if I represent in a waveform, here is your square wave. So 10 VPP in a sense, from 0 to the peak value, it is 5. And from again 0 to negative peak, it is minus 5. So totally minus 5 to 5, it becomes 10 VPP. So that is the value 10 VPP, and the frequency given has 1 kilohertz. You need to create an integrator or design an integrator where the input waveform is a square wave, and the amplitude or the peak to peak amplitude is 10 VPP and with a frequency of 1 kilohertz. So frequency in a sense, F is equal to 1 by T, and that value is equal to 1 kilohertz. So this is the given data. So we will proceed from here. So I can write to work as an integrator. We have an I will write to work as an integrator. To work as an integrator in an RC circuit, there is a condition that RC, the time constant RC, should be greater than or equal to 16t. Okay, so the time constant R should be 16 times greater than the time period of the input signal. So this is the condition. So, and I can write the given data. Frequency is given as 1 kilohertz. I can able to calculate time period T equal to 1 by F equal to 1 divided by frequency is 1 kilohertz. So that is 1 into 10 power kilo in a sense 3. That much of milliseconds, and it becomes kilohertz, 1 into 10 power 3 hertz, and it goes up, it become 1 into 10 power minus 3, and that is equal to, I can write 1 milliseconds. So time period you are getting 1 milliseconds, and the time period is the complete cycle. For considering a square wave, the time period is for the complete waveform, that is 1 millisecond. And if you take, this is time period t1 for half cycle, and the second half cycle it is t2. So t1 equal to t2 is equal to 0.5 milliseconds. Okay, so that is all. Now we need to assume, because as per the equation, R and C, R into C is greater than 16p. We don't know what is the value of R, and we do not know what is the value of C. So we need to assume any one value. So I'm going to assume the capacitor value C is equal to 1 microfarad. Okay. So I'm assuming C is equal to 1 microfarad. So I can rewrite the equation. R is equal to, C goes to the other side. So 16t divided by C. This is actually coming from this equation. Okay. And I can find the value. R is equal to 16t. So 16 into t value, you can go with the actual value 1 millisecond. Okay, so 1 millisecond I can write it as 10 power 3, 1 into 10 power 3. So that is written divided by, it is 1 microfarad, so 1 into 10 power 6, so I can write it as 10 power minus 6 that much of farad. Okay, so this is the value for R. So once you solve this, the minus 10 power 6, 10 power minus 6 goes to the top, it's become 16 into 10 power minus 3 into 10 power 6, and this 10 power minus 3 and 6 will cancel each other, and you will get 16 into 10 power 3. So it is 16k. 10 power 3 is kilo. Since it is resistor, so R is equal to 16 kilo ohm. So this is the value for R. So we have designed the circuit because it is designing the circuit. So you have the circuit like this: a capacitor, resistor a resistor along with a capacitor, which is the capacitor is parallel to the load actually. And the resistor value I can write it as 16k kilo ohm, and the capacitor value is 1 microfarad. This is how we design. Once you have all the values, you can put it into the circuit. And also they ask us to find output voltage. So as per integrator, we have the standard equation is there. For an integrator, the output voltage is equal to, the relationship is 1 by RC integral input voltage into dt. So this is another one condition. The output voltage is an integral of input voltage, and we have this 1 by RC as constant over there. This is the standard equation for integrator. When it comes to differentiator, you will get RC into d by dt of Vi, which comes on as a derivative. Okay, so you refer this equation. We can substitute all the values. So I am giving all the values into the equation. So V out is equal to 1 divided by RC. R is 16 kilo ohm, right? So I can write 16 kilo ohm. So 16 into 10 power kilo in a sense 3. Then into C is capacitance, that is 1 microfarad is equal to 10 power minus 6. Then integral 0 to here the output voltage, so I can go for semi like half cycle, or I can go for full cycle. So if it is, I suppose I am going for half cycle, I can take the time period as t1. So t1 I already mentioned, it is 0.5 I think. So I can write, or anyway I will go with t is equal to 1 milliseconds. Okay, I'll substitute that value of t later. And in the input vi input is one side, they given 10 vpp, so here it is 5. Half of 10 vpp is 5, so 10. Instead here we will write 5 dt. Okay, so I proceed further. V out is equal to 10 power 3 and 10 power minus 3 cancelled. I will get 1 by 16 into 10 power minus 3. And integral of 5 is a constant, so I can write integral of 5 I take out, here you have remaining t power 0 to t. Alright, so you will get 5 into upper limit minus lower limit. So since I have taken, see here I will show you, your complete square wave is like this, and you have a peak to peak value of 10 vpp, that is minus 5 to 5. Okay, so if I take only half cycle, then the peak, the voltage level is 0 to 5, it is 5. In that case I will be taking only half of the cycle. Okay, that means if I take the voltage as 5, I will take time as half of the time, that is 0.5 millisecond. If I take peak to peak voltage, V is equal to 10, in that case I will take both the half cycle time period, that is T equal to 1 millisecond. In that way I need to take. Okay, so here I am taking only half of the cycle. So if it is half of the cycle, I can write T is equal to time period T is equal to 0.5 minus next time period is equal to 0. You will get like this. Since it is 0.5, it's milliseconds. Okay, so milliseconds means 10 power minus 3. So the whole divided by 16 into 10 power minus 3 is equal to 5 into 0.5 milliseconds means 0.5 into 10 power minus 3. The whole divided by 10 into 10 power minus 3. Both are cancelled. So you will get, this is 16, okay. So you will get around 0.156 volt. This is your output voltage. This is in case of half cycle, okay. And if you want output voltage for a full cycle, then that we can write V out of PP. Peak to peak output voltage is equal to 0.156 into 2. So you will get around 0.312 volt. So this is the problem. Solution for integrator. I hope you understand.